When solving equations with trig functions in them, there's a couple of strategies that typically tend to help you and work out a little bit better. And that's what I'm going to go over in this video. So when you have an equation with trig functions in them, say something like sine of x equals cotangent of x, or something like that. So the best way to approach these are, first of all, you always want to try to get your trig functions to be, one method is to get them all into sines and cosines if possible. So we're going to get cosine x over sine x. So right away we can see here that sine x can't be 0 for this to work. The next thing you want to do is try to get rid of all of your fractions. So you would multiply by sine x and get sine squared x equals cosine x. And finally, another strategy to use then, once you've gotten to that point, or if your problem started out like this, is that if you have trig functions that are squared, or sines or cosines that are squared, remember that you have identities that you can use. The Pythagorean identity is the most important. So remember that says that sine squared x plus cosine squared x is equal to 1. That identity is really important because it lets you change from sine squareds to cosine squareds and back however you want in an equation. So this sine squared x could be replaced by 1 minus cosine squared x. And once you're down to one type of trig function, then what you can do is arrange this as a quadratic and solve, because you have cosine squared, you have cosine x, and you have a constant. So this could be a quadratic form with a substitution of cosine instead of x, for example. So other basic strategies for trig equations, and this goes mainly with respect to inequalities. Let's say like we had something similar, but maybe it was, where is tan x less than secant x? So the main thing you have to differentiate between using an equation or an inequality is that when you have an inequality, you want to avoid multiplying both sides by the same term, because if you don't know if that's positive or negative, then it could mess up your problem, because if it was negative, you have to flip the inequality. You can see with equations, you don't have that problem because you can multiply both sides of an equation by anything. But here, let's do that first step the same as the equation where we change everything to sines and cosines. So what I'm getting at here is a lot of people would immediately say, oh yeah, let's multiply both sides by cosine to get rid of them. You can't do that here because you don't know if that would flip the inequality. So what you want to do instead is subtract 1 minus cosine over to this side. So your goal when you have trig inequalities, like similarly to when you have just rational inequalities, is that you want one side of the inequality to be 0. And if you notice, in this problem, we already have a common denominator. So from that point, you would be able to solve this just like you would a rational inequality. Where is the top 0? Where is the bottom 0? That's where you could look for your number line. So for trig equations and inequalities, switching to sines and cosines is usually a good idea. Knowing your identities is extremely important. And then making sure that you convert all to one trig function if possible, or if you have an inequality, making sure you don't multiply both sides by the same value, and instead getting one side to be 0.